All right, so let's get started. My name is Tracy Carl, and I will be your moderator today. I'd like to welcome you to our webinar, New Server and Storage Saving Options, CapEx versus OpEx. This webinar is brought to you by Curvature and will feature Forrester analyst Richard Fichera. He is Vice President and Principal Analyst for the analyst firm Forrester. Also with us today is Brad Saguindel, a server and storage expert here at Curvature. Welcome, gentlemen.
Thank you.
Welcome.
Before I turn it over to Brad and Richard, I wanted to make sure that everyone is set up and ready to go, so I'll just run through a few logistics. All attendees are on mute, so if you have a question or comment, feel free to type it in the questions window of the GoToWebinar. I encourage you to ask questions since we will have a Q&A session at the end. You can also use the questions window to let us know if you're experiencing any technical difficulties. I encourage you to share your thoughts on Twitter. We will be live tweeting during the day today using the hashtag CurvatureWebinar. Lastly, we will be sending the recorded version and the PDF of this webinar to all of you so you can watch it again or share it with colleagues. So now I'd like to introduce our speakers. First, we'll hear from Curvature's server and storage expert, Brad Saguindel. Brad has a 20-plus year track record selling into the data center industry. His career spans many roles and includes sales management, business development, and strategic alliances work for technology systems and software sales at Sun Microsystems and Oracle. Our featured speaker today, Richard Fichera, Vice President and Principal Analyst serving infrastructure and operations professionals at Forrester. His research draws on decades of industry experience where he has provided insights and advice about servers and data center architecture and transformation. Richard's areas of expertise include core technologies with a focus on blade and modular servers, converged infrastructure, virtualization, and management of virtual data center resources, enterprise cloud infrastructure, and techniques for data center transformation. Once again, welcome experts. Happy to have you here today.
Thanks, Tracy.
Brad, Brad, why don't you actually go ahead and kick us off?
Sure, will do. So Curvature is the global leader in new, pre-owned, and secondary market data center systems and equipment. Over 30 years of experience. They have over 10,000 clients worldwide. Curvature also has over 650 employees, over 4 major data centers, and also they have experienced $300 million in revenue for 2015. What makes them very unique is that they actually have and carry systems certifications around best quality procurement and services globally around the world. So one of the things that makes them also unique is not only is Curvature a hardware provider, but their clients have asked them to provide services that currently the OEMs are providing as well. And that's extending the environment of their legacy environments, which includes NetSure, professional managed services, so something as simple as monitoring and asset management, but also includes smart hand services as well. We also carry our own Curvature branded products, so optical receivers and also even Tier 1 approved memory as well. So also from the hardware options and solutions, everything from pre-owned alternatives, whether it's Cisco, Juniper, Brocade, server and storage offerings from the top vendors as well, and partnerships with all the other accessory items as well that you would typically find in a data center environment.
Thanks, Brad. Richard, we'd love to have you transition here.
Okay, thank you very much. Okay, let me see if my controls work. Good morning, good afternoon, everybody. This is Richard Fichera, and the folks at Curvature have asked me to spend a few minutes and talk about some of the sort of general trends and changes we've seen in infrastructure, both on the architectural side as well as the operational side, and how these changes have affected the way people build and operate their infrastructure. So with no further ado, let me go ahead, and you've probably all seen curves like this. I mean, you know, they're everywhere, and what we have been in this period of exponential growth for decades now, especially since the beginning of the internet at scale in the mid to late 90s. the scalar number of things on the internet and all of the data associated with our activities are just mind-boggling. We're talking about billions of users, and there are almost 50 million computers installed worldwide. We're talking about exabytes and zettabytes of data, which are numbers that are so big that they basically don't make sense to most people. But more interesting than just the raw numbers is the latent complexity and the kind of pressures it puts on organizations. The scale itself is a stressor, but when you look at the need for integration, the way these changes have to layer on and interact with our legacy systems, the way that we have to recruit talent, we have to guess about the talent we need. A lot of this talent is scarce, and it's hard to find when you need it. And we have this general notion of information overload. And to my mind, the real killer here is not just the scalar numbers that we're dealing with, but it's also the architectural complexity, both at the applications as well as the underlying infrastructure. We've gone from an era of relatively stable and pretty linear relationships between the compute and storage and network infrastructure and the software modules that run on them, to a much more complex environment that has a number of characteristics that, scale and size aside, just never existed before. We now have very complex composite applications. We have systems of engagement. We have traditional systems of record. Some of these things are hosted in the enterprise data center. Some are hosted in the cloud. They are hooked up to point of sale systems and other enterprise, retail enterprise systems. We have an immense growth in social media and particularly mobile engagement, which means that these applications are composite, they're multi-channel, and they increasingly require immediate feedback. I mean, we've all experienced a website not responding, and collectively we have the attention span of a gerbil. If it doesn't respond in a few seconds, you go somewhere else. So these pressures have driven people increasingly to look at new architectures, new technologies for infrastructure, and to incorporate cloud. But as we look at these applications, they're changing even further. And in addition to being complex, they're now not just unidirectional hierarchies. In a lot of cases, the data flow is bidirectional, which adds even further complexity. So this underlying complexity has been one of the drivers that has pushed people to go toward cloud, using cloud and integrating cloud. And the integration of cloud, in the early days, it was just looked at as a CapEx play and as a scale, a scale on demand play. But now increasingly, data is generated in the cloud, used in the cloud, and also used in the enterprise. So we have to sort of look at a lot more complexity in both enterprise and the cloud-based infrastructure. Now, there's a common kind of a notion that if you don't, if you're using the cloud, you can just kind of like shrug your shoulders and turn your back on the enterprise side of the infrastructure. But I strongly reject that notion, because I constantly am talking with clients about the issues they face in building their enterprise side of the infrastructure architecture. And in reality, the infrastructure engineering and choices we make are even more complex in this hybrid environment. If we start out with the sort of hypothetical enterprise, and at some point they discover there is a cloud out there, and they start instantiating infrastructure as a service virtual machines, everything's working well. It's a great new tool for us to use. And then we realize we have to decide about adding some bandwidth to get between the enterprise and the cloud. So there's an engineering decision there. Then we start discovering we have mobile users. And we also like the notion of a cloud so well, we start building our own enterprise cloud environments internally. Again, major engineering and architectural decisions that are complex and ripple through how we build the rest of our systems. So we need more bandwidth. Another decision. Then we start getting complex enough. We need some cloud gateway functionality. So yet another procurement cycle. We need to hire some talent we didn't have before. We need to integrate it. We need the skills somewhere, and we need more bandwidth. Then we start looking and realizing, well, you know, a lot of our services that we're engineering are in fact making really want low latency access to the cloud. So we start putting dedicated systems into large data centers that have very high speed, low latency, millisecond class latency to the major cloud environments. So we start putting dedicated hosted systems in there. And then we realize maybe that we have, in addition to steady state loads, we have some peak loads that might be better served by looking at a bare metal infrastructure as a service. So we go look at somebody, we go look at Internet or SoftLayer or one of the bare metal cloud providers. And that entails yet another set of engineering decisions and partnership decisions and integration activities. And then we start worrying about storage. We have to start building some cloud storage connection because there's a lot of choices about where we put our storage. We can put it in the enterprise with a proxy for the cloud. We can actually start caching it in the cloud in these same hosted data centers that have low latency to the access to the cloud environments. We can start staging data there in dedicated systems so the VMs in the cloud have low latency access to enterprise data that we control on our storage environment. And again, we've got to add bandwidth to this. So what you've got here is a very complex picture of a layer of infrastructure of a layer and style of infrastructure engineering that really literally didn't exist 10 years ago. So not only does it require work on fundamental technology enhancements, it also needs a change in the way that we design and operate these systems. And sadly, there are not a lot of good tools out there to do this for us. In fact, there are none to do this automatically. So it's kind of one of these expert arts. And guess what? The experts are scarce. And they're expensive. So we need to continually evolve our design and operational practices, not only the technology, but how we acquire these skills, how we use them. There's still some fundamental work that needs to be done on the part of the vendor community in terms of better technology abstractions. Today, it's probably pretty fair to say that the server virtualization part of the landscape is in pretty good shape. Storage virtualization, which comes under a lot of different names, including software-defined storage, hyper-converged storage virtualization, is coming along very rapidly. Very major improvements in the last 18 months even. The network, software-defined network capabilities are still very much a work in progress, and we're kind of bogged down in a lot of conflict between established vendors with immense economic stakes in the outcome. But the fundamental message here is we have to start thinking about optimizing across a large range of infrastructure elements and network environments rather than worrying about sub-optimizing individual systems, which is kind of a capsule description of a lot of the previous generation of infrastructure architecture thought process. And at the same time, the industry, the fundamental industry that we swim in has changed immensely. And we all have a tendency to think about the industry the way we look at it today is, we think of that as being a stable environment because that's what we're focusing. We're looking down at our own toes and not looking at the landscape sometimes. But if you think about it, the change in the computer industry has just been absolutely astonishing, and it never has really stopped. Looking back to the day when I got my first paycheck in the computer industry, which was quite a while ago, of all of the major computer companies in business when I started, only one of them is still in business. And of the top 10 companies in the industry today, only one of them was in business when I started. So there's been immense change for decades. But recently, we've seen some huge transformations. And with these transformations come a lot of disruptions and need to reevaluate partnerships and skill sets. You know, IBM and Oracle are making major transformation even at the expense of taking hits to revenue and growth. HP, which not too long ago merged itself with Compaq and has now cut itself into two pieces. Microsoft suddenly loves Linux, and IBM loves Apple. These are alignments that even, you know, a couple of 3 years ago people would have laughed you out of the room if you'd proposed this. IBM, you know, the original giant of the industry, has been successively exiting lines of business to focus on these transformational opportunities in software and services. Dell has come out of nowhere and bought the biggest storage vendor in the industry, which, you know, it's practically a cottage industry trying to debating what that outcome will be, but we certainly know it is going to be different than it is today. And out of all of these changes, there's been a lot of stress and a lot of change in the way people look at traditional operations, maintenance, and procurement. These, in some cases, you know, different partnership alignments. As the vendor universe constantly changes around us, there are people looking at third parties to provide them some continuity, to provide them with skills they don't have. People looking at self-maintenance. Some people with large cloud-like environments and application services that tolerate failure of elements look at deferred maintenance. Some people are no longer replacing things the instant they die. Maintenance of distributed facilities can be different than the maintenance in the central enterprise. And most importantly, there's this matter of integration and the constant flux in skills. Most IT shops, especially when you get out of the elite, you know, rarefied upper tiers of size and money, cannot afford to keep on staff all the skills that they need. And I think it's practically a given that, you know, a very, very large percentage of IT organizations are regularly employing some kind of third-party specialist skills. So with this final thought about change models, I'm going to turn it back over to our host at Curvature for a little more discussion on some interesting options.
Thanks, Rich. This is Brad Saguindel. Great segue. One of the things that we found, and analysts have also found as well, that in reality, servers do last longer. And so a lot of organizations that we talk to are looking for alternatives and options when it comes to the typical 3 to 5 year traditional refresh cycle. So knowing that that they do have the ability to continue to using their legacy applications in the infrastructures that they currently have in place, the trick now to this is how do they continue to support this? Because in case, as we see here, you know, servers typically last anywhere from 6 years, and in fact, some other solid-state systems like networking devices last up to 10 years. So, you know, our organizations that we're talking to and we hear are looking for options around and how can we support these environments when the OEMs no longer will support these and want to push us into the next generation technologies. So typically what we have here is the previous generation from all the major vendors, and where the market is pushing them to is to refresh all of those, you know, better speeds, better feeds. But at the end of the day, there's a big CapEx hit that comes associated with that. And so what we're starting to hear is that there's exponential growth, as you had mentioned earlier. And so how do these organizations keep in line with the growth of both websites, both storage? It's a very difficult proposition to address. And so in most cases, what we've been hearing is that customers want us to have us or have a third-party provider support those legacy environments and even expand off of those. It basically changes the whole environment because typically you can't support an older environment. In fact, it exponentially gets more expensive as the item gets older. But with most third-party companies that are out there, that's just not the case. They work on markets of scalability. There is a lot of resources to help support that environment, both from a hardware perspective and also from a headcount perspective. A lot of third-party companies now have expertise in data center environments and networking infrastructures and storage, and hardware is readily available to support those extending the life of those equipments another 5 or 10 years in some cases. So a typical situation that we hear is that the manufacturers announce the end of life of equipment when the legacy environment is still working. And so decision makers are looking to find the CapEx funds to help either refresh those systems out in place of the new ones. And in most cases, it doesn't actually match the workloads that the infrastructure is supplying. So they're having to do some pretty unique things to help support those environments. The rush upgrade timetables, it's typically, I think what we hear is that most organizations don't have control of these timetables, and they're actually being rushed to go and upgrade these environments. And lastly, to support these old legacy environments, the soaring maintenance costs, it gets more and more expensive to have older equipment supported by the OEM. And typically, most of the software updates are available online publicly. Hardware is typically available, from third-party providers. We've heard stories from companies that just let their systems fall off of support, and they're just basically replacing them with alternative sources just to keep the systems alive because they don't have the CapEx to keep this, to expand or do the refresh on that environment. In the case study here, we have a large global pharmaceutical company, about $7 billion in annual revenue. What we see here is that this is a typical use case for a large enterprise organization. In fact, they feel that the pinch the most. They have multiple different sites, thousands of employees, and multiple data centers and networking devices to support. There's all kinds of services wrapped around that's required to keep that infrastructure up and running, with field support technicians, hardware fulfillment. Customers want to have them focus on the core competency and looking for alternatives to support these environments at a lower cost of service. In this case, we see a large global, the same company, they have the typical OEMs that are supported, Cisco, Dell, HP, NetApp, the traditional large OEMs that you see. Well, we have seen that Curvature actually, in this case, had taken the vital role in making sure that the customer's environment is up and running. And at the end, the CapEx savings and what we had seen is $1.5 million in the year. OpEx savings was about a little over $1 million a year just in the first year. And just in the networking side, the total projected savings over 3 years is pretty significant. This allowed the customer to continue to use their existing environment, focus on their core competencies in the mission-critical environment, and look at third-party companies like Curvature to help support and continue to support those environments moving forward. When the CapEx funds are released or come available, they can strategically start to improve their environments, but this gives them options that they've never had before. They have freedom from the typical 3 to 5 year refresh cycle. And in summary, what we continue to see Rich had alluded to earlier, had made mention earlier, is that storage and compute requirements, that they're continuing to grow. And so they're outpacing a lot of the IT budgets that are out there. Organizations are looking for alternatives and options to continue to expand and support the legacy applications that are out there. What they really want also too is taking control of their IT environments, and they want to be able to have the options to make these decisions when it makes sense for them, not for the OEMs. And for that, I will turn it back to Tracy.
Thanks, Brad. That was great. I hope you all enjoyed it. Unfortunately, we have run out of time for question and answers. Please use the panel of your GoToWebinar console to ask your questions, and be assured that any question you ask will get a follow-up. So before closing today, I'd like to thank all of you for your time and attention. We hope you enjoyed the webinar. You'll receive a follow-up email with a link to the recording of today's session, as well as a copy of our slide presentation. Also, feel free to continue to keep in touch with us. You can tell us what you thought of this webinar by tweeting @Curvature with the hashtag #CurvatureWebinar. Thanks again for joining us, and thanks, Richard and Brad.
Thank you.
Thank you.